Hello class, welcome to day 2 of our first of our course in probability, and so we're going to be talking about some intro concepts and notation. The learning goal that we're looking at today and yesterday was just learning basic terminology and components of theoretical probability. And some of these questions are going to seem a little bit more straightforward, but we use those just so that we can talk about the notation. So the success criteria is N of A and N of S, like, do you understand what those mean? And then what we're going to add in is the indirect method, a method that we're going to use throughout the first half of this course to help solve kind of more complex problems, but just going to introduce it for simple problems. So here's a question. Here you got little James here in the wooden train. A train is 4 paths and is equally likely to travel all the paths. Determine the probability that the train does not take the 4th path. So as a warm-up, so it's something you can think about. As you think about this question, we actually look at things like A and S and what they represent. So A is the idea of like taking anything that's not the 4th path, so path 1, 2, and 3. S is the idea of is the set of all paths, so all 4 paths. N of A is that like the number of ways to do not the 4th. There's also this idea of A prime that we're going to talk about. And so we would have done it in class, where it's just that one 4th path. And when we talk about N of, we're talking about like the number of, and so then we actually use the numbers like 1, 3, and 4 to determine the probability. Here's an example that we can work through the notation. You win if you flip a card that it's not a face card. So the question is, what's the probability of winning? So if you flip something like really what we call a number card, the reason why we say not a face card and not a number card is just to get this idea of the indirect method. And it's a simpler concept, but really what we are looking at is what's the probability of flipping a number card. So some definitions in this example: the sample space is all those possible cards, so each card from each of the 52 cards. N of S is the number of cards in the sample space. We really should be using capital S here, but so N of S is 52. There's 52 cards. The event A is the cards that are not face cards, and so this is the winner. That's what we want, so the number cards, and there's 40 of those. We also have A prime, sorry, I guess maybe we shouldn't say prime, but a complement. So there's either a dash or a C. It's everything outside of A. So if like A is the 40 number cards, then A complement is the face cards. It's not face cards, but like it's really just all the face cards. And so there's 12 other cards, and so you can notice that like the 40 and the 12 together make the 52 total, and that's always going to be true. So N of A and N of A prime, or N of A complement, is N of S. And the reason why we do this is because it just might be easier to figure out the 12 than the 40. And so it depends on the question, but it might be easier just to say, okay, there's 12 cards I don't want. And in fact, that might be how you answered the question. And the probability of A is really what the question's asking for, is it's just dividing the 40 by the 52, N of A by N of S. And so we get 10 out of 13. Just as a visual way to look at this, and we're going to look at Venn diagrams more later on in the unit, but just as a visual way, we look at A and A prime, and these aren't a certain size for any reason, it's just a stock photo. But together they make up the total, which is the rectangle. And so like together N of A plus N of A prime, or N of A complement, so everything outside of A, is N of S. All outcomes are included. We don't have another circle for A complement. It's just everything. There's only one circle here, everything outside of A. The probabilities, if you think about it, the probability of A plus the probability of A complement, like that's everything. And so it's 100%. We can rearrange that, so we can use like say we want to get the probability not by finding the 12 first, but the percentage, we can also subtract it from 1. And so it's the same idea. This is the same equation really as this, except probabilities would always add up to 1 or 100%. So this is like just to give you a visual for the example. Your number cards is the 40, your face cards is the 12. Together they make up the 52 or the 13 even, if you wanted to look at it like that. And the probability, if you added them, you get that 52 out of 52, which is 100%. And there's some questions.